Good morning, everybody. There's a chance I'll be on an airplane during the next Tech Talk, so I thought I would make a short video about driveline monitoring. Brad had asked that we start thinking about ways to monitor a driveline, and so I thought, well, ultrasonic's one way, so I kind of did some experimenting with it. But before I go into a demonstration, first I'm going to run through a couple slides here. So the first thing everybody needs to understand about drivelines is drivelines have U-joints in them. And U-joints are these swivel joints. And it's important that drivelines are not mounted perfectly straight, because if they're mounted perfectly straight, the U-joints don't get exercised and they seize up. So drivelines are always mounted at a very slight angle. But one thing that can happen is the little roller bearings inside that U-joint over time can start to wear out, and then the driveline will start vibrating. One thing that we should do as part of the project is put a dial indicator on the driveline, and somebody probably has already done this at ProFrac, but a dial indicator is a thing machinists use, and they come with a magnetic base, so you can just stick it onto the frame of the truck, and then you put the dial up against the driveline, and you can manually turn drivelines with a strap wrench when the transmission's in neutral. From the readings from the dial indicator, we'll be able to decide if an ultrasonic sensor has enough resolution. The first one I looked at, this one was on the RS Electronics website. It has a 0.025 millimeter resolution. That's about a tenth of an inch resolution. Now there are a couple other technologies that we could consider. One of them is laser, and another one is radar. I would think that laser probably might have some issues as far as dirt, and radar I don't think is necessarily good for close distances. Okay, so now I'm going to do a little demonstration video to show y'all how an ultrasonic can be used. Hey everybody, there's a chance I'm going to be on the airplane for the next all hands on deck meeting, and Brad had asked that we look into driveline monitoring. So I had these ultrasonic sensors. I thought, well, let's see what happens if we put an ultrasonic distance sensor on a driveline and measure the deviation. So I told ChatGPT to write some software for the ESP32 to measure the distance and calculate the deviation and send it out to serial port. And then I told Claude GPT to write some Windows software that displays the distance and it displays the deviation. And here, just to show y'all a baseline, okay? So we're going to use this top as part of the demo, and you can see that the deviation will sit around 0.1. That's just the the background noise, and the distance is at 4.28 centimeters. Okay, so I'm going to set up this top that I bought at Night Plaza from a lady that was selling them. It was kind of expensive. It was $3. And here you can see the deviations down around 0.6, 0.5. Well, so we were in a situation normal there, no vibration, no wobble for a minute. Now it's starting to wobble, and you can see the alarm goes off. The green line you can see goes up here. Ooh, it's going up. And now we'll set it back like the truck is stopped, and you'll see the deviation will go back down to 0.1. Okay. So, in conclusion, it seems like the ultrasonic works okay on rotating objects, and it also um, seems like it works okay on curved objects. So, it seems like it's probably feasible for it to work on a driveline.